Good morning and welcome to STEM Sherpa channel, and this is my thinking place. Today we're going to take apart a timer. It's broken and I encourage you to take apart things and see how they're connected and working so that you can start connecting and working along thought processes you have. What I've done is gathered a few tools such as my drill, my goggles, and other things like pens, pencils, tools that I typically need for documenting what I'm doing and for accomplishing it. The reason I know I need a drill is that prior I took out 3 screws and there's still one left in here that I can't. These screws are kind of interesting in that they've got 3 sides, which is kind of unusual because the manufacturer doesn't want us to get into it. Ahead of time, what I'm going to do is look and see that I've got 2 outlets, an on and off switch, and a typical clock with some flanges around the edge that can go in and out. And of course, I can plug this into the wall through here. First things first, we'll pick up a drill. Okay, so we'll split this apart. Got to make sure I'm not caught on anything. Here we go. This end, the thicker one, the business end, has most of the internal parts that we're going to look at. And the first thing I'm going to do is I'm going to photograph it. Maybe I can put it back together. So that I have a reference piece of how all these parts fit together. I'm not going to take this apart, but it still is nice to have a reference point. So let's put this aside and look at this working for a second. Here's the switch. It says on, and over on this side, timer on. So now the outlets are on. This is connected through this piece right here. And if I switch it back and forth, you can see that it pushes down against this black switch here. I recognize this as a switch. If this is your first time taking something apart, you may not recognize that as a switch, but it's just a small version of what you have on your wall. It has 2 positions, on and off. And see how this piece is moving up and down, off. The timer is going to be working, but the circuit itself is off. Now I can go from the end through the wires and to these outlets. We're going to take this out and lay it out for you so you can see the pieces easier because I've just got a jumble of wires here. Okay, I'm going to have to break some things, and so I want to make sure that I have permission to take it apart. Maybe now I can put it back together, but this is broken, so we'll just take it apart and feel free to dissect it, if you will. I'm going to watch these. I suspect they're all going to be held together by these black wires, so I'll use a little force and take this apart. Starting to come apart. There's that piece that I was moving. The switch. The wires are holding most of this together.
Well, there we go. Put it aside for a while. I just want to look at the interior here. Make sure you see what we've got. This is the front. It has the screw that I could not get out and the 4 other screws and 2 holes, and looks like one other thing here is the axis of rotation for the clock on the front. Every piece in both of these has a particular reason. For instance, I believe the switch, the black switch, was on these 2 posts. The motor was down here. Here are where the 3 screws that I took out, and then the one that I had to drill out. This is where the flanges go in, and the grounding post came out of here and was connected to some of these wires. We'll take these wires and stretch them out, take a look at them, and make sure we have everything connected. Looks like we broke off a piece to what I recognize as a motor. That's our first step. We documented how they went together with the camera, because at this point it's going to be rather hard to put it all back
As I said,
together.
I've got a jumble of wires in here, but the black wire, connecting wire, is going to lead from the inlets where the electricity comes in to the switch and around to these outlets, and we've got to somehow connect up. They've got the motor connected. We'll talk about that. What I'm going to do right now is take a piece of paper and I'm going to sketch this out and try to analyze what it is. It's a little hard to do with these small pieces, with all of this connectors and such in here, so I'm going to try to simplify this into a simple diagram. It's going to take me some minutes. This is, for instance, how Leonardo da Vinci used to keep notebooks. His notebooks are more famous and more important than his drawings, because he would draw out and work out details as he went along. So I'm going to draw this out. I'm going to turn off the cameras, and I'm going to show you that diagram in a minute that I come up with, and it's going to take several steps. So I'm going to turn off the camera and let you think about it perhaps, or just come back in a few seconds when I've got my diagram done. Thank you. This diagram reflects the evolution of my diagram for the circuit. I started off with wide wires and trying to show the outlets, the motor, and the switch. It is this part that is pushed in by the timer to complete the circuit, but the circuit is unclear. I made some mistakes, so I redrew it. So finally I've arrived. I will put this drawing on the board in a moment. I've cut out some of the parts that aren't necessary, but you can see that for the outlets, a wire comes in, and when I put something like a plug in here, it makes a connection and carries the electricity away to something useful like a light. What I need to understand is when this is pushed in, how this comes on, completes the circuit, but I also need to understand when this is pushed, how the timer pushes this in to complete the circuit. I have transferred 2 outlets, the flanges that let the flow of electricity, the motor, and the switch are in blue. The wires that connect these, most of them are in red. And I can start to draw a path, but I'm going to change 2 paths. One is the motor has got to be on continuously, so it will not go to the switch. The switch turns things on and off. I want the motor on continuously when it's plugged in. And the way that is done is it is connected to this outlet, part of the outlet, and this outlet. This is a very small motor. This is 120 volts. So they will put in, and I'll show you this in a second, a resistor that lowers the voltage and that's going through here, and the force that's going through here, so the motor doesn't burn out. If I hooked it straight in, the motor would burn out, much like a flash bulb would burn out. The other connection is, upon examination, is to take the electricity from here back to the outlet. Now let's trace the path of the electricity along the red. Obviously we can go up here, and by doing this closed loop, we've got a power source. We're running this continuously. The alternative is we want to control this electricity through the switch, so let's first get the electricity down to the switch. And one way of doing that is we can go down here, and we can go to this side or this side. But this is now open. We can't get it down to this circuit unless I put some type of load in here. An example of that be a light bulb. Now we can get electricity down to the switch, and we can turn the switch on or off. But now we've got a problem. We've got to get the electricity back up to here, back up to this, and that's why I'm in green. This path is only intercepted by this. If this is on, I've got a connection from here to there, then I've got a complete route through either one of these. If this is off, it doesn't work. The electricity doesn't go through here. And so I've got an on-off switch. We've taken it apart. We've got a path for the electricity. I'm going to have to think about it for a while to figure out what completes this circuit when the switch is off, in the off position. How are we going to do that? I'm Dr. B. This is STEM Sherpa channel, and we try to encourage rational thought where you go from a flow like we did with the electricity from point A all the way to point X. Thank you for watching.